In this lecture, here I am going to derive one of the very important result of complex integration, which is called Cauchy integral theorem. The theorem tells that if f of z is an analytic function and f prime z is continuous at each points within and on a simple closed curve C, then the line integral of the analytic function f of z over the simple closed curve C is equal to 0. So two conditions are mainly imposed here over the function f of z. First, analyticity of f of z, and second, continuity of f prime z. $1 million question may be raised here from the viewers: why these two conditions are so important to impose over the function? The condition continuity is important, as later on we shall use Green's theorem to derive this important theorem, and further for applying CR conditions and CR equations to simplify the result, function is compulsorily need to restrict under the analytic condition. So this is the reason why we are imposing two additional conditions over the given theorem. One more very important terminology is used here, that is simple closed curve. For that we need to understand the difference between simply connected region and multiply connected region. Let me to focus on the definition. A region is called simply connected if every closed curve in the region encloses points of the region only. Otherwise it will be called a multiply connected region. Now the question, for how many this definition is digestible? No, not at all. So for layman, let me to redefine it in different way. I can say if the region has no holes and it doesn't cross itself, no hole and it doesn't cross itself, then it will call simply connected region. Like the picture of this tomato, the front cover of this buckle which I use to tighten my belt, the frame of digit 3, this plate cover can also be considered. Let me take a very exceptional case. This is the shape in which this hanger is taken here. These all are the example of simply connected region. But a region having holes or cross connected region is called multiply connected region. For example, like this hairband or the switchboard socket or back cover of my buckle or the key of my sports bike. And a very good example is what this silver color plate. I can give you a very awkward type of example of multiply connected region. If you take two black eyes over your face, this is what if you look at the two black eyes over your face. Again an example of multiply connected region. Very simply or very easy way you can remember this last example by remembering a famous Bollywood song, Ye Kali Kali Aankhein, Koshiru Koshiru. Jokes apart. Simply connected region here we shall use for deriving the result of Cauchy integral theorem, and for extension of Cauchy integral theorem, multiply connected region will be considered. Let me to come to give a proof of Cauchy integral theorem. Let us take our region R which is bounded by a simple closed curve C. So the integrand f of z can be rewritten as u plus iv and dz as dx plus I dy, which can be bifurcated further as an evaluation of integration of two different real functions. ux, uy, vx, vy. Partial derivative of u with respect to x, u with respect to y, v with respect to x, and v with respect to y. All are continuous here, as f prime z is given as a continuous function in the statement, which sufficiently enough to apply Green's theorem. Now it reduces to 0 on applying CR equation. Here the result is